Alright, here we go. First part review. We're going to do 22. This place is a zoo. Alright, so on 22 it says JAE and EAF are adjacent and supplementary. So we have to take a look at these, right? Oh, jeez. What a weak start to this. Ta-da! Alright, so JAE is this angle, agreed? And EAF is this angle, right? Well, are they adjacent? Are they next to each other?
Yes.
Yes, they are! Do they form a line?
Yes.
Yes. So if you form a line, what do your angles add up to? 180. So does that mean they're supplementary?
Yes.
Yes, that means they are supplementary. Alright. Next thing's next. 23. EAF and JAD are vertical angles. So EAF is right here. JAD is right here. Alright. Are those formed by a pair of intersecting lines? Yes or no? Yes. Are they congruent? Yes, they are vertical angles. So yes, they are vertical angles.
Page
207. Oh, jeez, that's a lot. That's a lot. That's so much. What number is that?
13.
Alright, number 13.
And
Then
then 14.
14. Number 13, this is 120, right? If this is 120, what's angle 1? 120 because this is lower right, this is lower right. What do you call those? They are corresponding angles. Alright, so 1 is 120 by corresponding angles. What about 120 and 2? What relationship do they have? You have to, 2 is 120. What do you have to do with this line? You have to cross it. So it's alternate. And is it outside these two lines or inside?
Outside.
So it's alternate exterior angles. Right? Yes.
Considering it first line is
Yes, you could. You could have said 120 is 1 is 120 and then those are vertical angles. Yes. In fact, you just proved it. Okay, let's do this one. What's the relationship between 105 and 2? Let's do that one first.
alternate.
They're alternate interior, which means they are congruent. So if that's 105, 2 is 105. Now, what relationship does this angle and this angle have in common?
Same side.
They're same side interior, which means what do they add up to? 180. So that means I do 180 minus 105, which is
75.
75. Angle 1 is 75 degrees. Right? I think that's on pause. I hope so. Alright, here we go. 17 through 20 on page 274. So let's take a look at these. Let's try these triangles. Ha! Alright, on 17, we have one congruent side. What do you know about this line, though? Congruent to itself, that was reflexive, right? So I have a side and a side. Is that enough to say anything? So there is not enough information. You would... Nope. Because you don't know anything about these sides. Not enough information. Now, number 18.
Can you put another N after that?
No. Okay, on number 18, we have a right angle and a hypotenuse, right?
Right.
So is there anything we can do?
9 then.
Alright, now let's take a look at 19. I have a side. Wait a second. What relationship do these angles have? So what do I know about this? Wait, so I have a side, an angle, and a side. We got tons. If there's one thing I know, you guys have a lot of sass.
Specialized.
Alright, so next one. I have an angle, and a side. Is there an angle-side theory? What's that right there? Yes, angle, side. It's right there. It's right there.
Why do people
Page 44.
Alright, here we go. What's next page?
Page 344.
344.
Number 31.
Number 31. What page?
344.
What number?
31.
Okay. For this one, we have a triangle, and they give us angle measures, correct? So what I would do, oh no. Alright, what I would first do is draw a triangle, because I need to think that way. And I name it RST.
That's absolutely beautiful.
Thank you. Okay, angle R is 70 degrees. Angle S is 80 degrees. What's angle T? How can I find that? Yep, 180 minus 70 minus 80. Thank you. So that'd be 30 degrees. So now, those are my angles, correct? What's my smallest angle? So your smallest angle is opposite your smallest side, right? So this would be the smallest. So RS is the shortest. Alright, what's the next smallest angle? 70, which is opposite of ST. And then we only have one left. There we go. Alright, what's next page?
445.
445?
Oh, it's the gold escape. What number?
19.
Ooh, that's good.
Number 19 on page 445. These are similar figures, correct?
Yeah.
As it tells you. Let's see if that. So that means I can set a ratio, right? Like, should I say 12 over x equals 9 over 6? 12 over x equals 9 over 6. Agree or disagree? Now, how do you solve a ratio like this? Yep. So you get 9x equals 772. How do you get rid of that 9? So what's x equal? Yay. Am I done? No! 9. Alright, anyway. So what else I can set is 9 over 6 equals what? Y over 6. Can I do that? Cross multiply. 54 equals 6y. Divide by 6 and y equals 9. Oh man, I'm gonna remember this is a mess. How do I find z then? Same exact way. Z over 3.5 equals 9 over 6. Agreed? Hey, why am I using 9 over 6 each time? Why don't I use the other ones? Because if you did one of the other ones wrong, they'll all be wrong. Agreed? But if you always use what's given to you, you will at least get some of them right. So you'll get 6z, hopefully, equals, that's 18, 22.5. Divide by 6, divide by 6. Oh no, help, help. Thank you.
Page 482.
Nice job, third hour geometry class. What's the next page?
Page 482.
482.
19. 28.
19?
20 and 28.
Oh, that's perfect.
Alright, well, 19 and 20. You're going to want to go through and make sure you have these formulas on your formula card. Agreed? You're going to want to make sure these formulas are on your formula card.
Wait, so we're not going to use the exam formula sheet?
You make a note card. You get a note card for part 1, you get a note card for part 2. I collect your note card at the end of each part. Yeah, there's a bunch in the drawer somewhere.
I thought you said it's cheap, I guess.
Okay. Let's do 19. Now you can set the ratio. The ratio would be 12 over x equals x over 6. Or you can use the geometric mean formula, which would say that this part, x squared, equals 12 times 6, equals these two parts. Because it's in the middle, right? It's a geometric mean of those two lines. So x squared equals 72. So x equals square root of 72, right? Which, if you really got fancy, you would have done, what's that, 6 root 2? Now, to find y, what you have to do, y, you're going to deal with the 12 and the whole thing. So y, or you could have set up 12 over y equals y over 18. But you could do y squared equals 12 times 18. Because you see how these are both on the same side as y, right? Y goes with the 12 and y goes with the whole thing. So y squared equals 12 times 18. 12 times 18 is, help, 216?
Yeah.
216? Square root it, and that becomes, actually breaks down really nicely. Morgan, help me out. What's that become? Oh, I'm on wrath. 6 root 6?
Yeah, 14.
Well, it said simplest radical form, so they wanted you to break it down. Do like 4, and this would have been 20, this would have been 40, this would have been 50, 54, and then this would have been, what, 20, why am I doing 26? 27 and 2, this is falling downhill quickly. 9 and 3, 3 and 3, 2 and 2. I could have, but I'm not. 2's make it out. 3's make it out. 2 times 3 is? 3 and 2 are left in there. 3 times 2 is? 6. Alright. I made you guys do 20 as well, right?
Yeah.
Alright, good.
Yeah.
Alright, number 20. So this one's in the middle, right? So this one's the x squared equals 5 times 7. Equals this side times this side. So 5 times 7 is 35. Square root. X is square root of 35. That does not break down. Alright. That would have been about 5.89 or something. Alright. Alright. Any other ones on this page? 28 or 250? This is a good one. Alright, number 28. I love ones like these. These are parallel lines, right? Parallel lines, split it into equal ratios, agreed? So, this is already set up like a ratio for you, isn't it? 63 over 45 equals x over 55. Agree or disagree? You see how it's already pretty much set up for you. You just have to do this. Then you cross multiply, and you get 45x equals 63 times 55. Help. 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 One more. Say. Alright, how do you get rid of this 45 then? What do you get when you divide by 45? So x equals 77. Nice job, team. Alright, this is page 496, number 24. Alright, to prove it's a right triangle, what's that big theorem we use all the time? Pythagorean theorem, yep. So you're going to set up a squared, should be using, plus b squared plus b squared equals c squared. So what's 19 squared plus 20 squared? 716? What's, whoops. What's 28 squared? Alright, does 761 equal 784? No, so it is not a right triangle. If they did equal, it would be a right triangle, right? Alright, what's the next problem we have to do? 535. I'm not afraid. Which one?
19 through 9 to 12.
Oh, 9 through 12?
All is small. And then 14 through 17.
14 through 17. Rolling. Action. Okay, this is going to be all cut and disjoint and awkward and weird, but what else isn't about my life? So, on number 9, I'm going to do this the quick way. Look. Oh, man. Wicker biscuits. Oh, man. Look at, they have the ratios over here for you. Remember those ratios I told you were that come up all the time? And then you guys are like, I don't like them. This is a 45-45 triangle, right?
Right.
Which means if this is x, this is x, and this is x root 2. Agree or disagree? So if this is 7, what's this side? So what's this side? Ta-da!
Plus you.
That's how fast it is. That's it. Now for number 10, this gives you the hypotenuse, right? So we need to get x. So we set this equal to x root 2. How do we get rid of that root 2? You divide by square root of 2, right? So x equals 10 over square root of 2. But wait a second. They say they don't want square roots in the bottom, so how do you get rid of it? Times by root 2 over root 2. So you get 10 root 2. What happens when you times the square root by itself? Square root goes away, it becomes 2, right? Jimmy Crickets. So that's 5 root 2, right? Because 10 divided by 2 is 5. They want it to be in radical form. Now you could have used trig on this. You would have went sine of 45 equals x over 10 multiplied by 10, right? Now if you do that, you get a decimal. If you're taking a multiple choice test, plug in your answer choices in your calculator, see which one gives you the same decimal. Agree? Alright. So now number 11. This is a 30, 60, 90 triangle, correct? Alright. In a 30, 60, 90, oh, jeez, that's a 45, 45. Jimmy Crickets. Oh, jeez. Oh, jeez, that's 60, 30. Your short side's x, your long one's 2x, and this one is root 3x because there's 3 different sides. So now for 11, do they give us the short, medium, or long? The short. So if that's your short side, what's your long side? 2 times 6, which is 12. How do I find my medium side? What do you have to times your small side by? Root 3. So your medium side is 6 root 3. Any questions, comments, and or concerns? Again, you can still use trig. You use like tan of 30 equals 6 over x. Sine of 30 equals 6 over y. Alright? Now for number 12, what side do they give us? Long, medium, or small? Papa bear, mama bear, or baby bear? Get it? Goldilocks, Goldilocks. Alright. They give us the long side, right? If the long side's 14, what's my short side? How did you get 7? You divide by 2, because that's 2x, right? 14 divided by 2 is 7. So it means my medium side is 7 root 3. Alright. 14 on the stage. Aye, Captain. Alright, 14, we need to find sine, cosine, and tan of A. So let me tell a story for those of you who might not have heard it. SOHCAHTOA. That's my story. Is it a good story?
Yeah.
Thank you.
No problem.
Thank you. That's what I needed in my day today. So first thing I need to do is sine of A. So if I look at this angle, what am I looking for? Opposite, hypotenuse, or adjacent? I need an opposite and a hypotenuse, right? So what's opposite of this? 2/19. What's my longest side? 20. So is this it? Am I done? Can you reduce it? Root 19 over 10? Can I do that? You can reduce if you want to. You can leave your friends behind. Friends. Anyone know safety dance? I changed the word so if you would have noticed. I made them worse. Alright, cosine of A is... Cosine, I need adjacent, right? Which one's next to it but not the hypotenuse? 18. So that's my adjacent, and my hypotenuse is still 20. What's that reduced to? 9. You should. It says multiple choice, and the multiple choices will be reduced. 20. I just reduced. I divide both by 2. Yep, just that was right. I just reduced it. And now tan, let's get tan. Oh, I used lower. Tan is opposite over adjacent, right? What's my opposite? 2/19. What was my adjacent? What's that reduced to? Divide both by 2. You get root 19 over 9. Alright, let's go to 17. So this one we're looking for an angle and we're given sides, right? So it's a little bit different than most of the ones we've done. So I need to set up a trig ratio. When I look at this, oh my gosh, this whole thing. Oh no. You guys didn't see any of this trig stuff I was talking about. Anyway, if you have questions, ask them on Monday, please. Alright, so there's my angle, right? And my side ratios are opposite and hypotenuse, agree or disagree? Opposite, not touching it. Hypotenuse is your hypotenuse, right? So which one of the trig things has an opposite and a hypotenuse? Sine. So I'm going to do sine of x equals my opposite over my hypotenuse, right? So first thing I do is I set up a ratio. Now how do I get rid of sine? Sine inverse both sides. Ross, what are you doing here? You should be getting ready. Yeah. Sine inverse both sides, and when you sine inverse it, what do you get? 30x equals 33.1 degrees. Alright, so use the inverse.